Good day everyone, my name is Jackie V. Hamisola from grade 12 Mendel. Today we will tackle about calculate the period and the frequency of spring mass, simple pendulum, and physical pendulum. Objectives: at the end of discussion, you will be able to determine the spring mass constant and the natural frequency of the system by measuring the period of oscillation for different masses. To understand how the period and the frequency depend on the mass and the spring stiffness. To determine the acceleration due to gravity by measuring the period of a pendulum with a known length. To calculate the period and frequency of a rigid body oscillating about a pivot point. To use the period and the frequency calculations to find the moment of inertia of the body. Spring of mass. In this system, a mass is attached to the end of a spring that has a certain stiffness, known as the spring constant. When the mass is pulled down or stretched and then released, it begins to oscillate, move up and down, or back and forth. In short, a spring mass system works like this. When you stretch a spring with a weight attached and then let go, the weight moves up and down repeatedly. The spring stiffness and the weight's mass determine how fast it moves. If the mass is heavier, the motion is slower. If the spring is stiffer, it moves faster. Formula in period of spring mass. T is equals to 2 pi square root m over k, where T is equals to period or one complete cycle. M is equals to mass of spring represent in kg. K is equals to spring constant represent N over M. And the formula of spring mass and frequency is F is equals 1 over time, where F is the frequency in hertz, 1 is the number of cycles, T is the time takes to complete one cycle in seconds. Example: calculate the period and frequency for a 75 kg mass attached to a spring with a spring constant of 300 N over M. In the problem, our given are M is equal to 75 kg, K is equal to 300 N over M. Solution. In solution, we will use the formula of period. T is equal to 2 pi square root of M over K. Now, distribute the given in the formula. Copy the 2 pi square root of M, which is 75 kg, divided by K, which is 300 N over M, equal, copy the 2 pi square root, and the result of 75 divided by 300 is equals 2 pi, and the square root of 0.25 is 0.5, and then multiply the 2 pi and 0.5, and the answer is 3.14 seconds. Now we will get the frequency. The formula of it is F is equals to 1 over time, equals 1 over time, which is RT is equals to 3.14. After that, divide the 1 over 3.14 is equals to 0.318 Hertz. And that is the answer of period and frequency of spring mass. Next, simple pendulum is just a small weight on a string. Its period depends only on the string length and gravity, not on the mass. That's why a heavy ball and a light ball swing together if the string length is the same. So, a simple pendulum is made up of a small weight called a bob hanging from a light string. When you pull it slightly and let go, it swings back and forth in a regular motion. It does not depend on the mass of the bob. This means that a heavy ball and a light ball of the same string length will swing at the same rate. This happens because in gravity, all objects fall with the same acceleration. So both heavy and light pendulums feel the same pull from Earth. For example, if we hang a metal ball and a plastic ball on the strings of the same length, they will swing together in time. That's because gravity acts equally on both, and the length controls how long each swing takes. Formula in period. T is equals to 2 pi square root L divided by G, where L is the length of pendulum from the pivot to the center of the mass. G, acceleration due to gravity. Formula in frequency. F is equals to 1 over T, where F, frequency in hertz. 1 is equals to number of cycles. T is equals to time takes to complete one cycle in seconds. Example, a simple pendulum is 1.8 meters long. What is its period and frequency? Given, L is equals to 1.8 meters. G is a gravity, and we know that the gravity is equivalent to 9.8 meters per second squared. In solution, the formula is T is equals to 2 pi square root of L divided by G, equals copy the 2 pi square root, and L is equivalent to 1.8 meter and G is equivalent to 9.8 meter per second squared, equals copy the 2 pi square root, and the answer of 1.8 divided by 9.8 is equals 0.1837, equals again copy the 2 pi, and the result of square root of 0.1837 is 0.4288. After that, multiply the 2 pi and 0.4288, and the result is 2.69 seconds. In getting the frequency, the formula is F is equals to 1 over T, and RT is equals to 2.69. Divide the 1 divided by 2.69, the answer is 0.372 Hertz. The last is physical pendulum. Physical pendulum is any real-world object rather than idealized point mass that swing back and forth around a pivot point due to gravity. Consists of a rigid body that undergoes fixed axis rotation about a fixed point S. So, a physical pendulum is a real object, not just a small weight on a string, that can swing back and forth around a pivot point because of gravity. Unlike a simple pendulum, which assumes all the mass is concentrated at one point, a physical pendulum has its mass spread out over its entire shape, like a rod, a door, or a roller swinging from one end. It rotates about a fixed axis, a point that doesn't move, and the motion is caused by gravity pulling down on the object's center of mass. When you release it, gravity tries to bring it back to its lowest position, and it swings back and forth in a regular pattern. For example, a clock pendulum rod works as a physical pendulum because it is a real rigid body that swings about a fixed pivot under the pull of gravity. Its steady back and forth motion helps regulate the timing mechanism of the clock. Formula of period. T is equals to 2 pi square root L over mgd, where I is the moment of inertia about the pivot, m is the mass, g is equals to acceleration due to gravity, d is the distance from the pivot to the center of mass. Formula of frequency. F is equals to 1 over T, where F is the frequency in hertz, 1 is the number of cycles, T is the time takes to complete one cycle in seconds. For example, imagine a uniform rod of length L is equals to 1.5 m and mass m is equals to 6 kg, pivoted at one end. We know that the acceleration due to gravity on Earth is approximately G is equals to 9.8 meter per seconds squared. Calculate the moment of inertia, distance to the center of mass, period, and frequency. Number 1. Determine the moment of inertia. For uniform rod pivoted at one end, the moment of inertia is given by I is equals to 1 over 3 times ml squared. I is equals to 1 over 3 times m, which is 6 kg, times L squared is equals to 1.5 meter squared. I is equals to 1 over 3 times 6, and the square root of 1.5 meter squared is 2.25 kg times ms squared. And the result of 1 over 3 times 6 times 2.25 is equals to 4.5 kg ms squared. So our inertia is equals to 4.5 kg ms squared. Number 2. Determine the distance to the center of mass. For a uniform rod, the center of mass is at the midpoint. So D is equals to L over 2. Our D is 1.5 meter divided by 2. So the answer is 0.75 meter. Number 3. Calculate the period. Now substitute these values into the period formula for a physical pendulum. P is equals to 2 pi square root I over mgd equals 2 pi square root Ri is 4 kg times ms squared over 6 kg times 9.8 meter per second squared times 0.75 equals 2 pi square root 4.5 over the answer of 6 times 9.8 times 0.5 is 44.1 equals 2 pi square root, and the answer of 4.5 divided by 44.1 is equals to 0.102 equals 2 pi, and the answer of square root 0.102 is 0.319 equals 2 pi times 0.319 is equals to 2.00 second or 2 seconds. Number 4. Calculate the frequency. Use the reciprocal relationship to find the frequency. F is equals to 1 over time equals 1 over our time is equals to 2 seconds. So 1 divided by 2 seconds is equals to 0.5 hertz. And that is the answer of the example of physical pendulum. In summary, period and frequency describe how oscillations behave. The spring mass depends on mass and spring stiffness. The simple pendulum depends on length, and the physical pendulum depends on the body's shape and pivot. Thank you all for listening.